Greetings, 2%ers. I wanted to open with a spoiler alert for those of you guys who anticipate joining the paid channel. The good news is the designers are telling me that as of the release date of this video, we should be about 3 weeks out from launching the paid channel and the new Schrodinger's Box website. So more information coming on that. But the point of this introduction is the entire video for the diagnostics on this car behind me will be available on that channel. What I'm doing here is just giving you sort of a, not so much a teaser, it'll be a complete video here with the diagnosis and repair confirmation and all that. But what's going to happen in this video is I'm going to edit to just the introduction on what's wrong with the car and the symptoms, and then jump right to the final diagnostic, which identified the problem. The final diagnostic is a new technique that I don't think we've done on this channel before, so it had some relevance and I thought I'd show it. The entire video on the paid channel will show all the diagnostic approach that I go through getting up to that final point and all the misdirections and things like that. And then also it walks through the specifics of everything, if I need to use a wiring diagram, how I'm finding the things I'm connecting to, and I walk through very much step by step. If you're already an expert on that and don't need that information, then you won't be missing anything with this video. So this video is basically an edit from the entire video, and it will show the diagnosis and repair, but it just bypasses the path that I took to get there. A lot of you guys like that mystery, and you're right there along with me where you're trying to guess what might be wrong, and let's see if we do the same tests that we're both thinking of. If that's important to you, you will not want to watch this video and just wait for the video to come out on the paid channel, and you won't miss anything. The full video has everything you would see here anyway. But if you're not bothered by getting a spoiler, then you can go ahead and watch this video and still join the paid channel. So without any further ado, we will get you to this preview of the video that would be available on Schrodinger's Box Quantum Mechanics, and we will have more information on how to join that website. We're aiming for a price of $3.49 a month. That's $1 off of the original subscription, and again, more information coming on that. But enjoy the video either way, guys. We'll see you next time. Hey guys, hopefully got a good one here. We've got a 1999 Nissan Pathfinder that is just severely underpowered. It will not get out of its own way. And I've been driving it around a little bit. It's got a couple of challenges going on here. One of them is this car was sitting for about 2 years. So the battery on it is completely dead. You can probably hear the whine. I've got a battery charger on it now. I'm trying to preserve the check engine light codes. One of the things is the battery will just immediately die and you lose your check engine light codes. So we do have some direction there. I haven't looked at it yet. But the car, the symptoms, I kind of have an idea what may be going on, and the car feels okay. The engine seems fine, but it just lacks power, and it almost feels like you're pulling a 50,000-pound sled with it, or maybe driving with the emergency brakes on. And a lot of you guys will be familiar. If you've got a plugged exhaust, that is exactly what it feels like. It just seems like the car's running fine, but something is just dragging it. And that's exactly how this car feels. So we're going to go for a plugged exhaust first, but of course we want to establish our baselines by looking at our scan tool data. It's also possible there's other completely unrelated check engine light codes that we would want to make sure we get the DTC codes now that I've driven the car and got the check engine light to come on. There may be codes that are unrelated, and we also want to make sure when we return the car to the customer that we fix those as well. So we don't want to just go ahead and go after a plugged exhaust and then we find that's the problem, replace the cats, give it back to the customer, and then it comes back with a different check engine light problem. So let's do this. Let's start off with our data. One other challenge with these cars is I know that in the past my scan tools do not work well with Nissans. So I think the best chance I have is probably with my CRP Touch Pro. I know for a fact AutoTap and Auto Ingenuity will just give probably 7 PIDs at the most. So let's start there. Okay, here's a look at our codes. We can see we've got a 0325 knock sensor code. Certainly concerned about that, but I don't think that that's causing our problem. It may actually be possibly even a result of the issue. For example, the misfire here, definitely concerned about that, the 0300 misfire. And definitely, well, actually, no, I take it back. This 0161, that's a heater circuit code. So normally I would not be worried about a Bank 2 Sensor 2 code, but I was thinking that may go along the lines of my hypothesis of a catalytic converter clogged, and maybe we were getting, lean signal. But this is a heater circuit, so that is not going to be related, and that has nothing to do with anything except possibly a bad oxygen sensor. We'll certainly look into those, but right now I need to get this car running, and my main thing is certainly the misfire. So let's look and see what we can do for live data here. And yeah, this is what I was afraid of. As you can see, I don't get a lot of data here. So all kinds of things that we want to look at. One possibility is a throttle position sensor issue. That certainly could cause that effect where we're hitting the gas pedal and nothing's happening. Probably want to get some engine RPM, definitely fuel trim. One of the problems is that we need to get our oxygen sensors working. We're not in closed loop yet. So let me get this warmed up. We'll get into closed loop. Okay, I'm just going to add engine coolant temperature. And yeah, check this out, degrees Celsius. So let me get this warmed up and we will be back. Well, this is warming up. We'll give you a look at the engine here, and I can tell you the engine seems to have some vibration to it for sure, but it certainly isn't a single cylinder misfire, that's for sure. And it just has a funny sound. You probably can't. It just sounds, I don't know, it sounds muffled to me. You can see that, I don't know if you can see the date on the battery here. It says 112. So this battery is not helping me at all. I've got to keep it on the charger anytime the car is not running. Let's check our temperature and see if we've got into closed loop yet. This car has a bad oil leak. Let me just show you, I noticed this. See if you can see that smoke coming off there. And that smells like burning oil. Let me just take a look. Yeah, it's dripping oil right on the exhaust manifold. Is exactly what's happening. So that's off the valve cover gasket. Let's see if we can catch. Yeah, that should be showing up. So that's off the valve cover gasket. So another thing that I'll certainly be looking at before I return this car. That could be a safety issue, possibly. Okay, so let's try this again. Number 1 represents the right-hand bank. Look at that pattern. The engine is just absolutely noticeably different. Get back on there. Smooths back out. That represents the right-hand bank, and here's one that represents the left-hand bank. Look at the difference in the pattern. Not as much effect on the engine. See how there's not as much amplitude changing there? Same bank. Again, just not as much amplitude. Okay, so if that's bank specific, now I'm starting to think timing. Okay, hopefully you're following what I'm picking up here, but basically what I'm noticing is every time I remove a wire from bank 1, there's a fairly profound effect on the engine on any of the wires on bank 1, and you could see that in the RPM performance. And then on bank 2, any wires that I remove, there's much less pronounced effect on the engine. You could again see that on the RPM performance. And what I'm thinking is now there's there's probably a timing problem. Now, the only problem with that is why are we not getting a timing code? And I can't really answer that. Maybe the car hasn't run long enough. Remember, I only ran a couple drive cycles while I was trying to get the check engine light to come on after a dead battery. It's possible also bank 1 is properly timed and bank 2 is off time, and there's only one camshaft position sensor and it's on bank 1, so it doesn't know the engine's off time. I actually don't know. But right now, I do think before we do anything else, going on to fuel pressure or anything like that, the compression test that we listened to kind of sounded pretty good, but we want something more definitive. Okay, several ways I have available of checking timing. Now, for most people, of course, at this point, they would only be able to take off the timing cover and then get the engine to top dead center and check the marks and everything, and that's perfectly fine to do. Certainly nothing wrong with doing that. The only problem is if we take a look here, the timing cover here is actually all one piece here, and there is quite a bit of disassembly that would be involved in doing that, as you can see. So again, nothing wrong with doing it at this point because of process elimination. We've got good reason to go through that, but I just don't want to go through all that labor. Let's just get the scope out. And there's a couple ways to do this. Maybe I'll show both ways, but what I'm going to show right now is a very simple way. And we're going to overlay spark signal with a relative compression test. So I'll explain that in just a second here when we get set up. All right, I'm going to run through our setup real quick and all the settings that I'll be using, so you could do this if you have a scope. But do keep in mind, even if you didn't have a scope, we did make this diagnosis staying very low tech, especially considering we couldn't even use the scan tool because of the lack of parameters we needed. So you can still do this pretty low tech, but I just want to be 100% and cheat a little bit with my fancy stuff just to save me some time spinning bolts. So what I'm going to do here is, this is a new toy that I got. This is a current clamp that is a little bit different than my low amp clamp here that has a very small jaw opening. You can see the difference there. And the idea with this one is very often I was running into problems where the battery cable was too thick to use my low amp clamp there. And as a matter of fact, that's also the case on this car. So I'm going to set that up onto the battery cable that goes to the starter and connect that up to the scope. And then what I'm going to do for an ignition trace, because I want to time ignition with our cylinder compression, and I've got a couple things for that, but what I've opted to use, the easiest one, is this inductive amp clamp. And what we're going to do is put it on number 6 since we're suspecting the bank 2. And unfortunately, I kind of have a problem with this thing where it hasn't been working. So if that doesn't work, we'll try an alternative method. But that hooks up to the scope for channel 2. And this is going to allow us to time the ignition event on number 6. I'm not looking to do a spark firing trace or anything, examine the firing pattern and stuff. But what I need is just something that shows when number 6 is firing, so I can correlate that with the top dead center on the cylinder, which will be detected by my clamp here. And we'll explain all that in detail and how to set this up. So let's go ahead and get over to the scope. Let's go ahead and crank this thing. Okay, did not get to see that, so we'll need to pause and, oh wow, check it out. And not crazy about this trace at all. It looks like my spark line did not work. Not quite sure what happened there. Maybe I didn't turn the probe on, but I've got a problem here. And this is a definite problem. I do not like this. This is a negative pressure. If we look, see how these two are together? We're missing this peak here, and it's negative. So it's you can also see it again here. And it's kind of hard to tell because if you don't look at these a lot, it just looks like 1, 2, 3, 4, 5, 6, but you can see there's gaps here. So that, I'd like to get that firing line in there, but I really don't need to, because this is very clear to me that we've got, when you see something like that, it's very often because you've got the valves closing late, and that would be a timing problem, and it does look like it's probably going to be on a separate bank than where these peaks are. I don't know for sure because I don't have the firing. Let me see if I can get that firing thing to work, and we'll try this again. But what's going to happen is we're going to see the firing event is going to be happening after the top dead center. Okay, I think I got my probe connections good. Let's try this again. Okay, let's pause that, head back. And there's a firing event right there. It's not even close. It's not even close. So that's one. This is 1, 2, 3, 4, 5, 6. So the event will be after this screen. Let's go check it out. And there it is after this screen. 1, 2, 3, 4, 5. I could go back further, but that's all I need to see. This line should be right on top of the peak of compression, and it is not, and that is all I need to see. And then these negative guys going on here, we can actually show that with a compression gauge. So actually, let me do that. Let me get an old school compression gauge, and we're going to be able to reproduce just the compression events here with the compression gauge. So check this out. Okay, we've got a compression gauge set up in number 1, and I believe that this is probably going to show fairly normal. I have no idea what spec is, but that's not the point. This is just a baseline control. So let's take a look here. So you can see that we built up to about 150, and I'm not sure what spec is, but that's, again, not the point here. The point is that what I'm going to do now is move the gauge, and we're going to go over to bank 2. We'll go over to number 6, I guess, because it's the easiest, it looks like. And we're going to measure the compression there. And what you're going to see is not so much a different spec, but a different pattern of needle movement, I believe, based on what I saw from that compression trace. It's going to be a drastically different needle movement, so check this out. All right, well, that didn't show exactly the way I wanted. Notice we were considerably lower on the pressure reading, but what I was expecting was a much longer time for buildup to the specification, but since we didn't reach specification, that didn't really happen. So one of the things we want to do is just rule out that this is just a bad cylinder and that this is consistent with every cylinder on this bank. So basically all the cylinders on this bank should be around 120, and of course all the cylinders on the quote-unquote good bank would be around 150. So now what I'm doing is I've relocated the compression tester to another cylinder on bank 2, and this one I believe is number 4, yes. So let me get this set up here. And of course, what we're looking for here is that the compression will be the same on all the cylinders on any bank. So this one should also read 120. If it does not, then of course the problem is we'd have a single bad cylinder, but that is certainly not the case. So let's see what happens. We can see we once again repeated 120 psi. So we are looking like all the cylinders would be 120. Now, of course, we could test them all. I could, better yet, even go back to bank 1, try another cylinder besides number 1, see that it also reads 150. But the bottom line is the evidence is overwhelming here. We've got a timing off on one bank. The spark line and the scope tests also confirm this. So now we are fully justified in getting this timing cover off. So I don't actually do stuff like that anymore, but since it's very relevant to this video, I will go ahead and remove the timing cover and we will inspect the timing marks. All right, confirmed we do have a timing issue and now we can see it mechanically, but what I've done is I've brought up cylinder number 1 to top dead center, so I've made some timing marks here. Sometimes the parallax with the camera shows these as off, but these are definitely on. I confirmed that it is top dead center physically with the number 1 piston. And by the way, for those morons out there who go off on me for using the torque wrench, it's because it's a ratcheting wrench and it's the only 3/4 ratcheting wrench I have. But as far as, man, don't ever use a torque wrench to torque an engine, you don't know what you're doing. Well, all I want to know is I've got all the plugs removed from this engine and there is probably 10 foot-pounds of torque required to turn this engine over. So would you guys please, instead of babbling nonsense that you just parrot without even thinking independently, would you explain why 10 foot-pounds of torque required to turn this crankshaft is going to damage or put calibration off on my torque wrench? Thank you. Besides, I don't even use this as a torque wrench. I have a set of snap-on torque wrenches that I normally use. This I just use as a ratchet, but even if it wasn't, you got to think independently, people. Ask why. Anyway, enough of that rant. If we look over here, we can see I made a timing mark here. This is a factory timing mark on the engine cover. And then there is a little divot on one of the teeth for the cam gear here. And we can see that I painted that white too. Let me check in the camera here and see, because sometimes the parallax again is off. Yeah, it looks, I can tell you that it is perfectly aligned. Now if we look over on the other side though, which is a little bit harder to see. Okay, a little bit hard to see here, but you can see right here, see the screwdriver there, is my timing mark on the engine cover, and then we can see, and actually in the camera it looks like it's only off one tooth. Right there is my mark on the cam. From this angle it looks like it's off one tooth. It's actually lined up with this tooth right here on the camshaft. It's just the angle's a little different, but confirmed timing problem.